Hello and welcome to our presentation of 3skeng tools for SketchUp. First of all, we'd like to give you a quick introduction about the icons on the toolbar. First of all, we have the client. The client basically gives you access to everything relating tools, libraries, parameters, and tutors. By clicking here, you can add tools. Click here, you have access to libraries. You can browse through what's available and even get a data sheet of the content of the libraries. The library window is only active when functions are available, or parameters in this case. The tutor window is context sensitive, meaning whenever you activate a tool or function, the tutor is shown that is needed at that exact moment. To make things easier for you, we built in a window that gives you access to all tutors at once, and you can browse them through and learn without having to deal with any drawing in SketchUp. The other icons are pipe, channel, steelwork, edit and rotate, connect, label, and list. We will get to these tools in a minute. To show you the tools and functions, we will do a conceptual design of a steelwork construction that is home for a couple of fume hoods with exhaust, drain, and cooling water connections. We will start by designing our steelwork construction. So as soon as we click the steelwork button, we have access to the different libraries. So you can select between C, I, and U section. In this case, I just pick an American pile. So as you can see, the first thing you need to choose is the starting point. We just pick a random point here. Second, you have to decide what direction the profile is supposed to look in. In this case, you see that the main SketchUp axes are used and highlighted in order to ensure that you have exactly horizontal or vertical beams the way you want them to. By clicking, we just confirm the direction, and now we have to pick the rotation. So the scale you see now is done in a way that the inner circle allows you 90-degree rotation. One circle further outside allows you 45s. One more, 15 degrees. The outer circle, 5 degrees. And if you are outside, you can completely free choose the rotation. In this case, we just stick with the standard one. By clicking, we can now decide what height we want to have. On the small scale you see, the right side gives you a metric indication and the left side imperial. You can of course also input the length with your keyboard, which we will do in this case. As our 3skeng tools integrate seamlessly in SketchUp, we make use of the SketchUp copy functions if we want to duplicate our steelwork beams. Now we just give our small design a floor. To add a beam on top of this one, we just click the tool, select the direction we want to have it. In this case, it will lock exactly if you are adjacent to the top of the existing beam or if you want to be on top here. By clicking, you confirm. Here, you can select the chamfered beam, which doesn't make any sense here. So by clicking escape, you can just roll back one step. And now we can catch the length. As you can see, this is quite easy. Now we want to do a 90-degree in order to support the roof. So we just go on top here, and we can rotate the profile here. This button here allows you to change the size and even standard if you want to. We just go down a little and pick the direction we want to have. We want to have it here. And we want to have it end exactly here. So in order to align it in the center, we just use our SketchUp tools and catch the center point. So now our steelwork construction is finished in a way that we now can proceed to the fume hoods that are housed inside. Now that we finish our steelwork construction, we will add exhaust duct to our model. To fix the height, I will just provide a helper line to have my starting point for the duct. By clicking the channel tool, I pick this point and indicate the direction in which the duct is supposed to face. By clicking here, I confirm it. Now I have a selection between 5 different types. I have straight channels, reducers, elbows, tees, and pipe elbow, as we call it. It's a straight pipe piece that has already an elbow attached. I will start by using a straight channel. The first step here is to indicate the width. In this case, I just stick with 3 feet by 2 feet. By clicking, I confirm that, and I just give it a certain length. We can now delete our helper lines. We don't need them anymore. And now we will attach an elbow. The elbow gives you an indication of first what direction it's supposed to show. By clicking, you confirm it. The parameter over here lets you select either a round elbow or a rectangular elbow. We go with the round elbow, and now we can select the angle. In this case, 90 degrees. A click confirms that. The next step allows you to select the radius to diameter ratio. You just go with 1.5 and attach a straight shot to the top. Now we can add another elbow over here, which is facing in the other direction. If we make a double click now, it will automatically select the configuration of the previous elbow. Now is the first time that we use our edit tool. The edit tool allows us to manipulate either a pipeline steelwork or pipe, as later, and channel. By clicking here, it gives us an indication of what we can change. In this case, it's the length of the straight piece, or it's the height. So in this step, we just change the length. We will just catch the outer limit here and move it inside for a couple feet. We will attach another straight piece with a random length. So now we want to add a T-piece in our duct. We can do it in 2 different ways. By clicking the T function in the channel tool, we can either attach it at the end of an existing, or we can put it right in an existing channel, which I will do in this case. First step after this is to indicate the length. and its position. Second is what direction the branch will look. We'll just have it face this way. And the other step is to indicate the length. We will just go with 2 by 2, and now our T-piece is already finished. Now we want to make a reducer. First we indicate the length, and now width and height. The client gives us a possibility to change over the reducer to a round type. As I select the round type, it immediately changes the outline here, and it gives me access to the pipe conceptual library. So we just select the library we want to, in this case imperial steel ductwork, and we can select the size we want to have by using the pins. In this case we use a 14-inch steel duct. A click confirms the selection. The next point gives you an indication if you want to have it centered or off-centered in this direction, and now if you want to have it centered or off-centered in these directions. We just pick a center one. So now the functions of the channel are explained, and we will proceed by using 3skeng pipe conceptual in the next step. Before we continue with the exhaust duct, we will generate our fume hood. Let's just pick a size, fold it up, make a component called fume hood, and give it an indication what's the front. What I'm about to show you now is very important, as you can make all groups and components compatible to 3skeng tools. You can do this by adding a piece of pipe or duct or steelwork. In this case we select ventilation, imperial, pick our position. In this case I want to have it centered. Pick a straight pipeline, for example. Zoom in to get a better overview, and we select 6-inch. By clicking, you can now indicate the length, which is random in this case. And now, very important, you click on this piece of pipe, make a right click, hover down to pin outside visible, and activate pin 1. So pin 0 is always your starting pin. And as we want to have this pin 1, which is the end of our pipe, to be visible outside the component, means that 3skeng tools recognize this pin as a pin they can attach to. What that exactly means will be shown in a minute. Now we leave the component. Just move it a little away from the column. Duplicate it. So now we're done. Now that we have the fume hoods, I will show you how to use the pipe conceptual. So if we hover over this already existing reducer, it will automatically recognize the standard and size, and I can just continue to design the pipeline. In this case, an elbow. Selection again shows you where you want to have the elbow facing. We use face downward, 90 degrees, and a radius to diameter ratio of 1. We attach a straight piece, indicating 3 feet. Add another elbow facing on that side, double clicking to confirm the parameters. Make a straight piece of, in this case, 6 feet. We add a T-piece, which is supposed to be 2 feet long, and it's facing towards our fume hoods. So now that we have to select the size or the dimension of the outlet, we can hover over the fume hood and it will immediately catch the pin outside visible of this component and pre-select it in our T outlet. A left click confirms that and just leaves us the selection of the length of the outlet, which we will do. We just use these two components now, mark them, and use the connect tool for the first time. A left click allows us to either move the selected parts somewhere else, or by hitting the control button, just duplicate them. Now we will duplicate these 4 parts another time in order to have an outlet for each and every one of the fume hoods. To connect the fume hoods to the outlets, we basically have 4 possibilities. The first possibility is what we started out with. You just draw a straight pipeline, add an elbow, edit it to the appropriate height by catching this pin, add another straight piece, add another reducer facing towards this, 90 degrees, edit this one to catch this outlet, and do the final connection here. To be honest, it is quite fast, but it never seemed fast enough for us. That's the reason why we came up with a second solution, which we call the pipe elbow. In this case, we have to pre-select the direction in which the elbow is facing. Double-click confirms the last used elbow. And now we can catch the height of the outlet in this step. By clicking that, we can do the same thing by now doing it with the second elbow, and we finish the connection. But our software engineers went one step further, and we came up with the following by clicking the start pin and the end pin. It will automatically calculate which possible connections you can make, and if you make a left click, it will give you a variety of possible connections from the starting point to the end point. In this case, we just take our radius to diameter ratio of 1. And by now clicking left one time, the connection is done. I don't think it can be any faster than this. In exhaust, you sometimes have the requirement to do flexible connections. We can also do this. We just add a flex. Now we can see that we have a collision of this flex with our steel. In this case, we just hit the edit, hover over our flex, make a left click, and give it another bending point. Now that we have the possibility to lock the axis and move our flex away from the steel beam, and we have a good connection now. I will now remove this flex connection because I will show you something different afterwards, and I will just replace it with our connection like this and move the whole T-piece a little outside of the beam. So to show you the edit function one more time, you can, for example, move the whole branch, including all connections, wherever you want to have it, and a left click will automatically update all edited parts of the pipeline. It sometimes happens that in your project some parameters change. In this case, we got notice that the height of the building has to be reduced by 2 feet. We use the edit tool on our Steelwork and lower it by 2 feet. And see now that we have a lot of trouble with our exhaust. But if you use 3skeng, as you can see now, this is not really a big problem. So we can adjust the height very easy and fast. Now we want to use the detail mode of the pipe tool to add drains and cooling water supply and return to our fume hoods. In the first step, we will enter the component of the fume hood and add a connector. Therefore, we switch to the detail mode and select the starting point. We want to have a straight pipe, and we will use CVC pipe. If we zoom in, every pin represents one size that is available through the library, and therefore on the market available components and sizes. We select 1 inch and decide what length we want to use. We then add a connector. We want to have a threaded union female. We will copy the straight piece and the union to be our future cooling water supply and return. Now we can exit the component. In the detail mode, you don't have to select the pin outside visible for components because it's already predefined that way for all detail connectors. But let's continue with the sloped drain. First, we are only shown the selection of the possible counter connection for the female, which is obviously the male. And we select this. A pipe LO element will face down, but not totally. We select 280/65.5 in order to be able to do a slope. To counteract the slope at the end of the line, we have to do a slight horizontal detour. And now it goes down the drain. To make the connection between pipe and our drain, we click the T button on the pipeline. We are shown the available T's for that size. It's a reduced T, 1 to ½ inch, 1 to 3/4 inch, and 1 to inch as a straight T. When we pick it, we are asked for the final connection, and we will pick the reference to the female union. Have it face upwards. Now we have to apply the counter union and can use the auto pipe function of the detail to get the available connections with 45s and 90. We have to do the same for the 2 other connections. First, and the second connection. We can also edit this pipeline based on the free parameters. In this case, we cannot change the slope because the slope is locked due to the angle between T's and elbows. But we can, of course, change it in this axis. Now we will proceed with the PCW supply and return. We add the male counterpiece and use the pipe elbow to align the axis with the drains. Have another straight pipe. Now we want to add a ball valve. Align it. Add another straight piece. Now we will add a pressure regulator. Align this one. Have another straight piece of pipe. Add a valve. And another straight piece of pipe. Now we can pick all we need to do the other side. We will add a flow meter. And a valve. Now we can align the valves to the same height. And now our cooling water supply and return is done. To help others better understand our drawings and designs, we want to add labels and generate a bill of material. For both tools, list and label, there are basically two ways on how to work with them. The first way is to activate the tool first, and based on your selection, select what you want to either label or list. The other way, which I will use in this presentation, is to do the pre-selection first and click on the tool after. The tool will automatically either label or list everything that is part of your pre-selection. Now we have to left-click to set the starting point, and depending on the position of my cursor, it will use 2 lines or 1 line. Another option is to hit the Shift key and realign the main axis of the labels. On the parameter box, you see that you can select between long text and short text, and that you can add the information of material if you added a name to the name field, and you can add the material. Again, 1 line or 2 lines. Another very handy feature is the option count segments. If you have very big drawings that are really fuzzy because there are a lot of labels, you definitely want to check this box in order to clean up your drawings and help others better understand them. A left click confirms our selection. For the list tool, we do the same. We pre-select and hit the list button. It will generate all our selection and put it in our component list window. The copy to clipboard button allows you to work with all the information in other programs. Please look at those options. The count segments option will sum up, for example, all ball valves and count them up, in this case to 4. And you can also check the box total length of straight lines. It will sum up all the straight pipe 1 inch we used in our model. I hope I was able to show you how our tools work, and thank you that you were part of that presentation. Goodbye.